Hi everyone. Today I will talk about a project I'm working on since maybe now 2 years, mostly between contracts, and it came from the frustration I had for another project I worked for a customer where we started something around Barrel, which was another project I did, replicated database that you can find online, and my business plan at the time was to sell something over Barrel, so customizing every time for customers, etc., etc. So doing things for one customer, doing kind of the same thing for another customer, etc. So at some point, that was becoming very frustrating for me, but also for the customers. So let's try. I took the time to take all the bits I had to start a new platform. And this platform is about building a serverless platform for edge computing. This is all done in Erlang and some part in C++. And another language, as we will see. But the main part, the orchestration part, is in Erlang. And what I will describe here is how it works, what it's doing, and how it works in Erlang, and which part of Erlang are useful for that kind of applications. Okay, so I've already been introduced. I'm presenting myself as craftsman in edge computing and P2P platforms, which is what I'm doing since mostly than now 22 years, and my last incarnation as business owner is Enki Multimedia. With Enki Multimedia, I'm sponsor and founding members of board members of the Erlang Foundation. I'm still sponsors as of today, and I think that Erlang Foundation can be useful to help the ecosystem to grow in Erlang and other BIM language. So first, what is edge computing? So quickly, you can see the definition from IBM, which is distributed computing platforms that brings applications closer to data source, to IoT or local edge servers. Basically, that means that when you provide some content, when your collaborator provides some content at one office, it can be shared with another data center or another office, or maybe the cloud, depending on what you want to. And the other part of my platform is mixing both edge computing and serverless computing. And serverless computing is cloud computing execution models, which is mostly on demand, and it offloads all the responsibility that you have for developers to an application platforms. So the developer doesn't have to handle scaling, scheduling, patching, provisioning, etc. Everything is easy, etc. So what is about integrating serverless to edge computing? So first, let's take some concrete use case. So one of the first use cases for that, on which I am interested at least, is to building a CMS, a content management systems, where content is updated at the offices and shared between them and larger data centers when you want to share some context with your public, etc. So you have different ways to do that. Generally, you take some server on the cloud or some server in centralized place, update on that central place, and it's dispatched between your collaborator that connect to the intranet, etc. But as some may have seen last year, at least this was very effective. Sometimes the cloud is breaking, or sometimes your connection is breaking. You don't have any connection, but you still want to continue to work. So the point of having an edge computing platform is to allowing you here to continue to work on your content, share with your local collaborators. But at some point when the network is back, or when it is there, you share that with another infrastructure or another data center for backup purpose, but also sharing purpose, collaboration, or whatever usage wants to. One other use case, and everything started from that for me, is to build the business messaging services. like in banking, for example. In banking, at least in Europe, in Germany, Switzerland, etc., you have systems where when a company provides wages, salaries, paper, and want to send back to the collaborators, they send a message through the bank, and the bank is sending a message to the collaborators, and that's working well. And one way and the content is provided by the company, but share with the edge points, which is the banking system or another platform. Another use case for that is telecom platforms, like emergency services. In emergency services, you have that all that telecoms that is working by itself, but you want at some points to put in conference people between them. You want to put in conference the doctor with the one that is bringing the person, or with the caller that has an issue, etc. And everything is done by messaging, etc. And you want to have that in a way so that the content is provided by each edge points, which can be the car, it can be the police office or anything, and bringing back to the platform. And this is what I want, and this is what is allowed by such platforms. And the other things is maybe more simple is if you want to build some event applications and the event is happening on different places. And so, for example, I'm on a boat and I meet people on the boat, and part of the event is on another office, another part of the world. And you want to share rendezvous, meetings, a message to people, and continue to share that with other places, etc. And you can do that doing that kind of platform. And of course, IoT would be more complicated in that case because it requires more nodes, but IoT is exactly about that. You create content from different things inside in different locations, and you want to share that with the data center or share that with other platforms inside the city, etc. And that is allowed by that. Sorry. So this platform is about decomposing application in small units, functions, and so you have that part in serverless platforms. It's all about having a wide approach. I don't want to force someone to use specific platforms to dedicate, for example, a hard disk like some database do to handle data, or I really want that you can use any cheap hardware and put that on the cloud or put it in your office using refurbished hardware, for example, etc., refurbished hardware, and use that for your platform. Everything is event-driven, so there is no real state inside in application. It is shared between all and reconstructed on the application level when you need it. And computation is done closer on data source. So it can be done on the data center, but it can also be done in an office. It can also be done on your computer, etc. This is the next generation of parallel, obviously. And where the difference with other platforms is where, for example, HCI, hybrid computing infrastructure, focus on containers and distributed storage. I'm focusing on offering a peer-to-peer and customizable infrastructure where data and execution can be replicated between data points. And this is done mostly on-premise. Even if you can do that on the cloud, I would encourage any of my customers to do that on-premise or on the infrastructure when they can. And this is inspired by CouchDB, Kazoo, plus the feedback from customers that I have. So in the platform, there is 4 main components. The gateway, which is a separate controller that can replicate and forward documents between different nodes. It can also switch events directly from the application in the same node. Think it as like a router that you can have, except if it's not done on the network level, but on the data layer, on the data level. Then you have the application servers, many application servers that are run on different places, like gateways, which is containing the execution logic and handling the interaction with the user and external application. Then you have the database nodes, basically the barrier nodes that support local storage and exchange events that are taken by the gateway and sent to the applications. And the last one is the assembly, which executes some custom function in WebAssembly when you don't want to write something in Erlang. So roughly that looks like this. I deliberately taking the design of this platform, which is named Napshu. I'm taking that very rough because I really want to be able to make it customizable by the customers so they can handle their own business logic once again. Everything is done as a monolith. You can create one release and deploy it, but you can specialize the launch of each part. So you have one release, but you can decide to launch the gateway on that release, or the application note, or the database storage. That is the update of each element if you want to. So you can deploy some release independently, and you can also, and that is also the CI. Application in applications server are Erlang application also, an external application call from it. I will talk about that later. So the database engine, this is a storage, which is a fake layered storage, layered database. Everything starts over the file system using RocksDB, and I'm using my Erlang RocksDB bindings for that. In RocksDB, everything is abstract and presented to any layer on top as attribute index system. So you can store any attribute and property inside RocksDB and use that. And when you want to store that, you can store the data as blobs. They are not stored in RocksDB, but in blobs.db, which appear to be built with RocksDB, but that's different. And on top of that, I built an index that you can create, which functions, and then you can build any layer on that. By default, there is one layer, which is the JSON layer that allows you to index JSON and looks for JSON. But if you want to build a SQL layer or anything like it, you can do that, just like you can do that in Foundation database. And each layer is a fake an application. So you have one OTP application per layer, which allows you to have custom supervision, which allows you to eventually start and stop that layer on that particular machine if you want to, but also allows you to update that layer using a upgrade if you want to. And you can do that for different layer you have. So right now there is that JSON layer that is public, but and available for all. But there's also a SQL layer that is tested, even if it's just for aggregation for now. And you add a layer by deploying a new instance. So you build your release on your corner by your CI and do an upgrade if you want to on the other nodes. Until you don't change the RocksDB bindings versions, you just have to upgrade your application on top of that. That doesn't change, and do the migrations you want to, even that. And the same for the applications nodes. Each applications are OTP applications that are listening on events. So each OTP application coming with specific modules or more than one modules. That is a listener, which the only role is to listen on events provided by your application and by other applications, and also other parts like database nodes. So you get the events you want to filter on that listener, and you can, if you want to, you can also persist a state, a snapshot of that event received by the application on that, using again Persist, another part of the framework, which is even written in Erlang, which I show quite later. And events go through the gateway only when needed. So if you want, if an event is about to tackle one application which is on the same node, it won't go through the gateway, but also sending event by event, like Kazoo does, for example, or some other application does using RabbitMQ, can be very exhaustive. It can exhaust the bandwidth, it can exhaust the CPUs, it can exhaust the RAM. So the system try as much as possible to buffer events and send them by batch from the application layer to the other applications or to the database through the gateway. Since all OTP applications, since all applications are also OTP applications, that's also allowing you to make easy deployment and customization. So you can create an application, build a new release, launch a new node, and start to deploy that on another nodes. And when everything is good, shut down your other nodes if you want to. And this is, and the beauty of Erlang also is when you want to make some upgrades and you don't have C code in your Erlang applications, then you can do auto upgrade if you want to. And that is working pretty well right now. This is an example of, again, Persist. Again, Persist is something I wrote 2 years ago that I never been able to release quickly, but it's now about to. Basically, you pass events, you pass comments that will be sent to the assembly layer. You can also pass any other events and decide to persist them or not if you want to make a snapshot or reuse snapshot for the application. So if you relaunch an application, if you relaunch an instance, it will take the last snapshot you stored, get back the event from that and restart from that. And the snapshot is stored on the database nodes, of course, and can be replicated by another place. Yes, you can add different applications like a transaction engine and anything like it. And yeah, so anything is good, but it requires you to hire some Erlang developer, which can sometimes be very difficult, and sometimes you don't want to do that. You may want to be able to use another language or another kind of developers that can create some other kind of applications. We use some framework, like if you do some intelligence, artificial, etc. I wouldn't try it in Elixir myself. I would try language that actually do it in Java or maybe in Python, stuff like this. So you can use a developer that do that, write its applications and put that in the platform. So in CouchDB, there was a Couch app, which doesn't exist really today, which was a server language written in Erlang, where you had chosen a list function that allows you to show and list document, and this function were evaluated in different language using NIF or external processes. And all the code was evaluated line by line in the loop, which was not efficient, etc. And you had that client in Python or Erlang or Ruby or NIF in your language that allows you to send that application to CouchDB and to be executed in CouchDB. This application were replicated between different nodes, etc. So you were able to build some interesting parts. Unfortunately, some people didn't see the real interest in that, and it was really forgotten at some point. And this is really a missed opportunity in CouchDB, to my point of view. And what you can do today with Snapshot, so this is a specific application in Snapshot, which is launched, and it's really working like Cloudflare Worker, if you know that them. So you log to an application nodes, connect, you can create an application and send this application to create a database on the cluster for this application and publish that application to an actual node. This application doesn't have to be in Erlang. It can be done really in Python or C or Rust or any language. This application is in fact converted in WebAssembly. So where the Couch app engine forces us to write an if, etc. per platforms, it was difficult to have the same application engine workings both on FreeBSD, Linux, Windows, and many things. Here we are building WebAssembly, and WebAssembly is executed on request or on change on each application nodes. Result can be persisted because they are sent back to application through the gateway. The difference also with that is, so when you create a function and function emit events, event can be catched by any applications that really I want to subscribe to it. So you can do many things with one event provided by one function in the platform. The assembly engine is written in Zik because it was easy to write WebAssembly with Zik. And it's connected as a C node to Erlang. So you can deploy many application engine in Zik on different platforms. And these execution engine are registered to the gateway, send event to the gateway, or receive event from the gateways. There can be more than one gateway. And these events are sent back or coming from the applications or many applications. And functions are stored in the database nodes, can be replicated between each edge points. So storage node can be replicated to one database center, one data center, to another office, to your desk, computer, etc., etc. HTTP 1.1 is approved for that. Since I'm the writer of Acne, I decided to reuse Acne. And this is a really coming version. So Acne doesn't have HTTP 2 right now, but it will have very soon now, this month at least. And HTTP 2 and WebSocket are used to provide events and to pass events, etc. The other part is handled by Cowboy, which is one of the best right now HTTP 2 server handling the system. And it appeared that Loic is a French, so it's quite more easier to talk with him when it's needed. Storage is handled by custom storage pair or RoxyBI. I talked that. It's about it can persist, which is using WebSockets to talk between nodes. Why it's using WebSockets and not in TCP, etc. This is because I have some customers which are working on different countries, and some countries have some proxies. And using TCP or just SSL is very easily proxy filtered or forbidden. Using WebSocket, never. To ensure the sustainability of the projects that will work like this, everything will be open source, but you can optionally use one of managed controller provider on platform in Europe, which is self-hosted. Hosted on different data center, but in Europe, so privacy is handled, and supported customization. So I'm quite excited to show them open source release that will happen now on 23 November. The go live is on 23 November for different customers, and that will be open source that day on my website, not the meter. And voila. And if I don't know if we can have some question or extra, but yes, I'm done. Thank you.
You can feel free to add questions to the Whova app or unmute yourself now to ask Benoit something.
If you want to, I released the new version of Erlang Proxy today, so if you can use it, you can use it as of today, even if it's not on XPM because there is a limit right now.
So thank you so much, Benoit, for your presentation. And I think we're all pretty excited to see what comes of this. Great stuff.
Yeah, thank you.